this video, we are going to learn some more commands in assembly language. So hopefully you've already done the tutorial on input, output, and halt, and we're going to build on our knowledge a little bit here. So it still holds that the number one rule is that the current value that we're working with is always in the accumulator, and that's going to be really important here. So we've got three new commands. We've got DAT. This creates a variable, and absolutely unlike Python, we create all of our variables below all of our code. It's just the way assembly language works, and yeah, like I said, so we'll see how this works, but all the all the variables get listed below all of our code. Then we've got LDA, which stands for load. This is going to load a value from memory. So from our RAM, we've got a variable, we're getting a value from a variable, and we are putting it into the accumulator so that we can use it, maybe to output, maybe later to use for an if and else, but we're bringing it from memory into the accumulator. And then store for STA kind of does the opposite of load. So it will take the value from the accumulator and store it to a certain variable in memory, and we can choose what variable that is. So let's look at a few examples. So first off, we've got this very basic program. We're not going to see much happen here, but let's just look at it. So we input a value. Now, as soon as that value is inputted, so for example 9, that value is stored in our accumulator. All right, so we've got that value 9 in our accumulator. And then on line 2, we've got STA, so that means store A. So what that does is it takes whatever value is in the accumulator, in this case 9, and it stores it into our variable called A. Now we know we've got a variable called A because we've got this ADAT at the bottom. So after our halt, we've defined a variable A. It'll start with its initial value of 0 because we haven't put anything here. Doesn't really matter. But whatever is in the accumulator is going to get stored into that variable A, and then the program stops. So not too much is happening because as soon as the program ends, our memory will be wiped. But that's how that one program works. Now, this is a bit more complicated. So we ask the user for an input, all right? We store that input in variable A. So we get 9, we store 9 in A, so that variable A now holds the number 9. Then we input another number, 8 in this case. Now, let's say we want to go back to our original number. Well, 8 was in our accumulator, and this 8 is going to get lost because on line 4 we load A. Okay, so whatever was in A, we're copying into our accumulator, all right? And then when we output on line 5, it's going to output whatever was in our accumulator, which is 9, outputs 9, and then the program stops. And again, we've got that ADAT created at the bottom. So again, kind of a senseless program because we didn't really need to input this, but you can see how when you've got a value in the accumulator from input, for example, when we load, it overwrites that value. And the last one, so this program is going to input two values and output them in the order that they were inputted. So the way it works is we input a number, that number gets stored in A. So if we start with 5, 5's in our accumulator, then 5 gets stored into A. We input another number, which overwrites that 5 in the accumulator. All right, so 4, and then we store 4 into B. All right, so this is why we need to store, because if we want this value 5 back, it has to be saved in a variable. Now, on line 5, we've stored both of our variables. So now we've got load A, so we're going to go to A, which is 5, and A gets copied into our accumulator, so we output A, which is 5, and then on line 7, we load B, which is 4, and when we output B, it'll output 4 because 4 is in our accumulator after we loaded it. And then the program stops. So notice we've got that ADAT and BDAT down at the bottom, and again, that just defines those variables A and B so that we can use them in our code. And these load and stores are really, really, really important. It's how we create variables. So line 1 and 2 in Python would be the equivalent of A equals int input. And then line 3 and 4 would be B equals int input. 5 and 6 would be print A, 7 and 8 would be print B, and that would be our program. All right, but here we've got to do it a lot longer. We've got to consider how we're working with that accumulator. Great, now let's have a look at doing this live where we've got our trace table updating and we can see what the output actually is. So we're going to read two numbers as input, store them in variables x and y, load x and print it, and load y and print it. So very similar to what we've just done, we've just got variables called x and y. So I'm going to input value, and I am going to store that in x. Now, I'm going to delete this in a second, but in assembly code, this is just the equivalent of x equals int input. That's what we've just done on those two lines. Great. Now let's have a look at doing this live where we've got our trace table updating and we can see what the output actually is. So we're going to read two numbers as input, store them in variables x and y, load x and print it, and load y and print it. So very similar to what we've just done, we've just got variables called x and y. So I'm going to input value and I am going to store that in x. Now I'm going to delete this in a second, but in assembly code, this is just the equivalent of x equals int input. That's what we've just done on those two lines. Not what we want. All right, then I'm going to do the same thing with y. So I'm going to input, I'm going to store it in y. All right, now I need to load x because I want to output the first one first. So actually, let's just go ahead and run this so we can see where we're up to. Great. So we've got this unknown label x on line 2. This is because we haven't defined our variables yet. So at the bottom, we have to say xdat and ydat. Now we can run it. So we're waiting for input. So let's do 5. And notice we've got 5 in our accumulator. And then on line 2, we store that 5 in x. And then if I input 3, we've got 3 in my accumulator and 3 gets stored in the variable y. Okay, so the program's working fine so far. But if I were to just output now, it would be 3. And I want to output the first one first. So I need to load x back into my accumulator before I output, because whatever's in the accumulator is going to be outputted. And those lines there are the equivalent of, that's print x there. And then I want to do the same thing with y. So I'll load y, output y. And then I just need to remember to halt at the end of my code. The inters don't matter, but just a bit tidier. Right, let's try that. So let's try the example actually so we can make sure we get it right. 3, 4, and it outputs 3 and 4. So it's worked correctly, and you can see here where it's copied from the accumulator, and then when it's outputted whatever was in the accumulator. So that seems to have worked correctly. Let's check our answer, and we are good to go.